Okay. Good afternoon to all of you. I welcome you all to this webinar organized by Department of Applied Sciences, Parul University. With immense pleasure, I, Neharani Vadhwa, feels honored to welcome Dr. Twinkle R. Singh ma'am on behalf of Parul University team. Let me first introduce Madam. Madam is currently working as an assistant professor at SVNIT Surat. She has completed her PhD in the year 2008 at first student of SVNIT Surat. She has total 11 years of teaching experience. Her area of research are fluid flow through porous media, nonlinear partial differential equations, Burger's equation, groundwater recharge phenomenon, analytical approximate methods, and mathematical modeling. Under her guidance, 6 students have completed and 5 students are currently doing their PhD. She has been also associated with external funded research projects. Now, I request you, madam, to please commence with your presentation.
Yes. Thank you, ma'am, for nice introduction. And first of all, I am thankful to Parul University, Neharani ma'am, and Bharat sir, and your team behind this organization of webinar, and all participants, those who have given me opportunity to represent my view over here. So actually, in today's discussion, I have taken the application as an application point of view. One mathematical model I have selected over here in fluid dynamics, in fluid flow through porous media. Actually, before moving towards the actual application of the whatever field we have, we need little bit the knowledge about the porous media. So in my discussion, first I am taking a short view about the background, and then slowly we'll enter in the problem. Fine. So yeah. So first of all, I will talk about the porous media. Maybe you all have seen in your daily life like hard material, like solid. See, if we'll talk about our ourselves, we own our body, human body. We will consider our human body. Then we need our that lung and the heart, that solid means can as equal as considered as a porous. So actually, porous we can consider it is one kind of solid structure means can say, and inside it, if we will mind it geometrical that structure of the porous, it is like the irregular like shapes of voids, or we can say like as equal as pores we can consider. Maybe you all have seen blotting paper, right? Fine. If on blotting paper, if we'll keep the one drop of ink on it, fine. So slowly the way means whatever structure means as a paper we have blotting paper in all the pores whatever will be designed. It is designed in it means all in all the not actually partially it will see that in the first side we will see yeah accepted all pores will be means can be filled with fluid, but maybe the can assume or and actually I think reality will be there, not exactly all pores will be filled with the fluid means yeah, yeah in the consideration. See actually yeah I have taken as a porous medium. Actually porous medium it is a it's a solid we can consider, and it is consisting of the pores. Fine, either the pores are well designed, or can say the not that much amount of that space means will be there means maybe small amount of pores can be there, or large amount of pore. If large amount of pores will be there inside the geometry of that pores, means fluid can easily pass into each pores of the porous. Fine. So yeah, it is cited. Yeah, like fluid as a fluid, we can consider even water, and even we can mind air, even and oil, even. Fine. So here, pore actually it is represents a certain portion of bulk volume, a complex network, and it's formed with is form which is able to carry fluids. Actually, the design, that interconnected, that what we can say, that geometry, that structure will be of the porous will be there in such a manner, is able to carry the whatever liquid or fluid means have uh, uh, passed means in the problem. And see, many examples means we can consider in the porous media, and so many applications means can see over here. And even I can say those who are new students over here and really they want to do interdisciplinary work. So this is the best I think can say. I'm not forcing to anybody, or you also do work with the fluid. But those who are able to connect, I mean, your own discipline with the application, so it's too best for industry even, and as well as society even, and even for the academic also. So over here I have highlighted few applications, like in soil science we can say, and in the porous medium it's solid, it contains, and even in the transport phenomenon in related water means can consider, even the nutrition of plants means we can work. Then the in hydrology means the porous medium is a water bearing and sealing layer. Even in the chemical engineering means still it means nowadays means many they are doing interdisciplinary work with science. The person with those who are in the mathematics and even in the chemistry person, and porous medium it is applied as a filter or catalyst bed. And even in the petroleum engineering, in the industry, so many applications are there. I don't know, but we mathematician only, we are in the institute also over here, and even whatever we have our own knowledge in mathematics, whatever means approximate analytical tool we have, classical method we have, numerical approach we have. Even those who are in the engineering, even they students, they have seen so many applications during that PG course maybe, and maybe with their job and with their other work, maybe they are working. So means the knowledge whatever we have, we can implement and can do best means whatever means society and industry need. Fine. So this is the good applications can consider in the petroleum engineering. Fine. Whatever the maximum amount of that recovery of the oil can mine with the help of the mathematical method. Fine. So over here I have first cited about the history of the porous media. Actually, what I felt I should say something. What about the origin of the whatever the medium we have? Fine, then maybe slightly means unknown interest can develop in the field. So here, if I will say then porous media, it's first that work it was started in the Porous Medium Institute. It was in 1987 in the Porous Medium Institute. Fine, and then onwards in the 1990, the flow models and related work in the subjective intensive research and phenomenon means slowly it was investigated means as per the needness. Even in the 1980, so many means the means problems which had been considered related to porous media, and it was in the University of Essen. Fine, and even major contributions in this the whatever the concern law means we are implementing into in the enter in the how to means react or connect whatever our needness and to mathematics logic. It is started with the Henry Darcy. Henry Darcy was the person. Actually, he has his own experiment as per his own neatness in those days in 1856, and even by mistake whatever he has done. And luckily, we mathematician and we researchers, those who are working in fluid side, means we have he's like Godfather, and whatever the laws he has means given over here as a reference, we are citing in our work. Actually, if we will see the way research means is going on in over here, means in India and in the abroad, even our many students, and even I have heard so many means our friends and our senior colleagues means those who are in the field, the really the way the laws should taste it, whatever the ready-made we are accepting, yeah, this is the Darcy law, and with the velocity related to constant fluid, whatever we need, that as per reference we are using over here, and automatically means we are connecting to our problem. But no, over there they will do it practically. Is it how much it has accuracy means in it, and once it is means it is proved, yeah, it is validated, then onwards means researchers can means use it and can cite in it related phenomenon. So it's a means can say means big efforts means over there, and even it's a good appreciable work means can consider the way means the work means are there. See, and over here, even introductory form of the fluid flow in porous media, I have cited one figure over here. Actually, in figure it is try to explain, just I said the fluid when it is entering in the porous structure, porous medium. Fine. So see, once maybe you people are knowing whatever the way we need entry to means in some unknown place over there, or over where we are not knowing, we're not familiar. So first of all, we should be aware with the whatever the means the essentiality and the ancients are following over there in that region. So exactly is over here, and fluid will try to enter in the porous medium, means it has to follow whatever means norms and ancients will be there, properties will be there. It means should satisfied over here. So over here actually nothing big it is over here, but only it is implemented whatever the shapes of different shapes of pores means, or voids means we have designed over here, and in it with the interconnected that the channels are over there, and the way the fluid is passing, it is only just expressed over here, fine. And yeah, and then exactly that examples I have actually taken to the book of Jacobier and E. Seidinger. See, actually, this is the porous media. We can say porous media. It is a porous material. We can say consider porous material. It is a one kind of solid body, or can say frames or matrix, and it is over here formed with the interconnected networks of pores or voids we can consider. And once it is filled with a fluid, or fluid means can consider liquid, or we can mind as a gas, suppose. Fine. So over here, when we enter in the interconnected that like channel means inside the porous, then how which type of means then onwards means the circumstances will rise that we can mind in our applications, and can design some assumptions in the mathematical structure. Fine. So over here only I have cited the examples. Yeah, this is the photographs of the natural porous media. It is available on the even on the websites, and it's I have taken from the books. Fine. This is the natural porous media we can consider. And yeah, over here I have added about the type of porous media. See, those who want to work in the suppose means the what is actually porous media and how we can enter. So even in the porous media, so many means the means way we can consider the look of the porous. Actually, only simply if I will say means only whatever I have cited over here in my discussion, a type of porous media, homogeneous porous media, and heterogeneous porous media. See, in homogeneous porous media and heterogeneous porous media, how it can be differentiated. See, whatever the related properties or actions we are considering of the medium means will normally means if variation will be there means in the medium, or many times maybe because of some whatever the parameters or assumptions we have set in the phenomenon, and according to that, if no variations we are mining at what we need our result in our problem, and according to that means we can differentiate. So in homogeneous porous media means no variation here means will be there in the permeability and porosity. They are the means properties of the medium, and in heterogeneity medium actually continuously means variations will be there as per whatever time and space means changes means we can mine in the permeability and porosity. So this only I have cited over here, and again I have added this figure over here as a 1.1. Actually, over here, I don't know. You all are able to see few capital A, B, C, D, like the way I have blocks. I have highlighted over here. Actually, it is B sandstone, limestone, red wood, whatever the example means can consider. Human lung means are blocks means are expressed over here, and as per this reference I have taken, and then onwards I have started about the discussion in the phenomenon I have one consider. Actually, this is one problem I have added over here. So let me talk about first whatever insight means and how a means that can arise as per the necessity. Actually, in the porous media, if you will see in my structure, the whatever mathematical structure related to finger vibrations phenomenon. Over here, what I have tried to involve over here, it is related to how much amount of saturation means are able to mine at the end of the finger imbibition phenomenon in fluid flow through porous media. Actually, if the name, if you will heard, then you maybe you people are those who are not much more familiar with this word. What's the meaning of this finger imbibition phenomenon? Actually, what the way the mechanism it will work over here, the way we are considering the fluid means in this mathematical model. Over here, we have considered. Yeah, let me to first figure and then I will come on the discussion. This is the figure I have means taken over here. This is the figure of the cylindrical piece of the homogeneous porous matrix means we have considered over here. It is fully saturated with the native liquid. Over here, native liquid as a oil we have considered over here, and as a injected fluid as a water we have means assumed over here. Fine. So our this work it is as on the base of logic of mathematics means we have stepwise we have considered over here. See what is actually inside the problem. See in the problem it is like this. In this mathematical model, here semi-infinite piece of homogeneous porous matrix, which length is L. It is over here, and it is fully saturated with native oil. Fine. And over here, water precisely weights the medium and slowly will give rise to imbibitions. Okay, let me come on the word imbibition. See, maybe you people are saying what is madam is saying about the imbibition and fingering. Actually, in this, what I am talking about this finger imbibition phenomenon over here. In this phenomenon, first what happened? If practically, mathematically, and definition, everything I have cited over here. Even you people can read on the on the web page, and too many good materials you can read. But see, authors, individuals, workers' own view towards the problems will come when we will think our own way. We'll open window of our own mind as per the necessity. Then we are able to say much more clear about it. Actually, what I mean, I can say imbibition. It is one kind of mixing of the two fluids. See what I said. I said the homogeneous porous matrix. It is fully saturated with the native liquid as a oil over here, and one side injected water is there. So when actually in the figure it's so like sophisticated way I have expressed the shapes of the figure over here. So, but before the shape of the figure, what happened? Little bit amount of mixing of the two fluids, two liquids first will rise at the common interface. See, common interface means like this. This common interface means we can consider mathematics at the middle of the portion of the semi-infinite porous matrix. We are considering over here. Over there, first of one kind of mixing of the two fluids will be that. It is the imbibition first will occur over here, and actually it is first addressed by Professor A.P. Verma sir about this the simultaneous occurrence of these two phenomena. fingering imbibition phenomenon. Actually, word it is finger imbibition phenomenon, but first of all, imbibition will rise over that, and then little bit amount of slowly we can say the layers of whatever the oils will mix with the because of the opposite side good amount of force of water. What I said, it is injected means liquid we have because of its good amount of force over here. After mixing, after this imbibition, can say the little bit amount of slightly layers of oils as equal as like fingers we are able to see means at the middle of the structure over here. What I have shown over here. Yeah, let me come on a problem over here. Yeah, what I was saying over here. Yeah, I was saying in this actually I have taken the finger imbibition phenomenon. This finger imbibition phenomenon it's occur in the even application it is cited over here. Those who are attached with the industry and they have good that opportunity to work with it, and they people can use this logic of mathematics means it and can recover whatever related to oil recovery process. Fine. So actually over here what happens when water is injected at common interface. Fine. Fine. And it is occurring due to the content of water and oil at common interface due to viscosity difference. This all means is going to take place over here because of the viscosity difference over here, and related it non-linear partial differential equations for this concern that this structure whatever we have assumed over here that we are solving with the help of the approximate analytical view over here as a homotopy analysis method. It is discussed over here and under certain assumptions and initial guess value fine related to solutions. And over here at the end it is concluded the saturation of this injected water is slightly increasing very near to the common interface. Fine. When length of finger increased for whatever time we have minded, time t greater than 0. Fine. When time is more than 0 in that circumstances, and even if coding means it is done over here. So this is the introduction. Yeah. In introduction points we have added about the homogeneous porous media. When weighting means like that type of that ability means have liquid as little bit amount of absorption naturally will be there means that fluid has its own that ancients. Fine. So weighting and less viscous fluid displays non-weighting and more viscous fluid, such that non-weighting phase moves in the opposite directions to the weighting phase, and means weighting phase move in the direction of the displacement. And over here, in this present case, the force mediating the displacement are the external force due to the injection of the weighting and less viscous fluids. So that is a spontaneous flow of weighting fluid. As a weighting fluid, we have minded over here is the water into the medium, and counter flow of the resident fluid from the medium. And actually, instead of the regular displacement of the whole front, little bit can say protons can take place and will shoot through the porous medium at a good amount of with the speed, high speed over here. And just I said, as per the reference, Professor A.V. Verma sir in 1970, sir has given his own view about the simultaneous occurrence of these two phenomena. Fine, and then the problem of the simultaneous flow of indivisible fluid in porous media, and in particular the problem of water oil displacement, both means force and spontaneous, is fundamental to the modern simulations of transport in porous media. And then I have added over here many researchers' contributions in this field over here. Professor Mehta sir and Professor A.T. Verma sir, their work in 1978, and they have said, with the logic they have tested about this, and they have minded it average cross-sectional area which is occupied by fingers. as means I have added in the figure. I will show in soon. And then the reference of Ruth and Bertley means I have added over here. Fine. And then in 2012-13 work of the Kinjal. In it we have work related this phenomenon, but in the concept of power series form. And we have still we have added about the whatever the prediction we can say about the maximum amount of oil means at the end of the phenomenon. And then in the work of Vyas, Nisha Vyas, we had worked with Mehta sir. In her work we had actually, yeah, what I have added about the type of the porous media with the concept of magnetic fluid effect, magnetic field. With the presence of magnetic field, will it be different than the normal phenomenon, whatever we will consider? Then how much means variation and how we can differentiate that we have worked in her thesis, and we have tested related phenomenon of the porous media. Fine, and then Meher and Mehta, they have worked about the adovine decompositions method. Even this is an adovine decompositions method. Even I can say it's also is a one kind of approximate analytical method. Actually, you will see about the different techniques means in the evaluations means as a research point of view. So approximate analytical method. When I have referred about the researcher Sinjun Layo, who is the main person, Sinjun Layo, and in his thesis he had added about the work related homotopy analysis method. Actually, this word homotopy, I will talk in the solution, but over here I have added. See, homotopy actually it is one kind of, we can say, deformation from one form to another one. Fine, actually this word it comes to the topology. Fine, I will come and solution I will discuss. Fine, and now let me come on the statement. See, just I said to develop this model, over here we have mined the semi-infinite piece of homogeneous porous matrix of Lantal, and it is fully saturated with the native liquid as a oil. And since water preferentially weight the medium, and this gives rise to imbibitions. Fine, and that is spontaneous linear flow of wetting water into the medium and counter flow of the native oil from the medium. Let me add please about over here. I just said about the spontaneous linear flow of the wetting water. See, you people can, if want to work on the concerned model, and the way we are just predicting as per the initial guess in our phenomenon, whatever solutions we need. Sometimes that solution will come in linear form or in form of the not in linear form. Fine, and then that the what I can say shape of the flow which can be differed. Fine, even this is the one of the research which you can include in your assumptions of the structure of the mathematical model. Fine, over here, just I said over here. Fine. See, then onwards, what we have assumed over here, we have assumed that the injected water it is less viscous and preferably wetting phase than native oil. The phenomenon of fingering oil occur due to injective force over here, just I say. And simultaneously, with imbibitions means the finger imbibitions means we have expressed over here in the figure 1. Just I have shown this figure 1. In this figure 1, this is this side injected water it is. Through arrow it is shown over here, and this black these portions it is as a native liquid, as a oil means it is assumed over here, and between this middle of the semi-infinite porous matrix over here at a common interface over here means can talk about whatever the circumstances will rise over here. So this is the representation of the finger imbibitions in cylindrical force of Lantal in homogeneous porous matrix. It is expressed over here, and a few again assumptions means are cited over here. Means those who are really need means fine, to develop the means the structure of the model over here. See over here, even we have added in this model to determine the saturation of the injected water. Matlab what the simple, if I will practically say the logic means it will work over here. Whatever maximum amount of the production means maximum amount of recovery of oil we need. Actually, this thing can image or can work over where from the in the oil formatted traps in the oil reservoirs over where actually in the well advanced so many expensive methods are available, and through that, but this is our mathematicians view over here. Fine, fine. Because this is as per the logic of mathematics means we are discussing. How way means over there our mathematics means can help. Fine. Like this concept, it is cited here. See what I said, that to determine the saturation of the injected water at the common interface, x is 0, is very small. जैसे कि यहाँ पे at common interface means over here. Fine, over where the amount of saturation is capital S suffix W0. This the meaning of this capital S suffix W0 means saturation of the water. Saturation of the S suffix W0 at the common interface. And how it is considered over here? Value actually as suffix W0 value, it is as equal as considered over here 0.1. Actually, as per the necessity we have used over here. How when x is 0, when x is 0 and at this much time, this many amount of saturations it is considered, and again it is considered that the initial saturation of the injected water. Initial saturations means when time t is 0. When just started to observe about the whatever the prediction about the how much amount of the saturation of the injected water. So when time t is 0, at that time it is considered over here capital S suffix WC. Like capital S suffix WC, and whatever the saturation when at the initial time we have guessed over here, that will be little bit less amount than the saturations we have guessed at the common interface. मतलब कि जब खुद x 0 है, when x is 0, at the moment we have guessed it is capital S suffix W0. Fine. So this is the means in the assumptions means we have sketched over here that I have explained the meaning of the, and the governing approximate that mathematical model actually over here provide the non-linear partial differential second order partial differential equations for this concerned phenomenon. How it will means can say that I am coming on that one, and even the homotopy analysis method it is implemented over here. Yeah, now let me involve to you all in it. See, just I discussed all this about the, I said the velocity of the injected water, it is increasing during the process of the water flooding, as means previous choose a cylindrical piece of homogeneous porous matrix of length L from vast natural oil saturated porous medium, and over here three sides are surrounded by impermeable surface except one end of the cylinder, designed as imbibition space x is equal to 0. And over here means one-dimensional model of this finger imbibition phenomenon. Actually, we have taken a vertical cross-section area of this cylindrical piece of homogeneous porous matrix of length L, and that we are able to see in the figure 2 over here. Yeah, over here, this way. At vertical, that cross sections means it is in 3D we will see that everything whatever is inside it, that mechanism is working, that way, all that means that process we are able to see. But over here only in the 2D means it is expressed over here. See what I was on this line, and it is expressed in this figure, and as rectangle, and imbibition phase as is considered as x is equal to 0 over here at the middle. Over here, or even I have highlighted over here x is equal to 0, and the schematic representation of finger it is considered by imbibition phenomenon it is given here. This is the main that contributions we should remember. A is Heidegger Johnson. This reference through this reference we have considered over here at this much level x Fine. And for mathematical study here, we have considered these irregular fingers. Irregular fingers means actually we have just image and yeah, finger shapes, but we will not that much amount of like two way sophisticated way means fingers we will be able to see at the moment. But slight we can say the means finger shapes means can because of it can say little bit amount of fluid can be stable. Fine. Yeah, and over here actually the to measure the saturation of the injected, actually not conductive water, injected water for the given length x and for time t greater than 0 as per the reference. And yeah, again as per the reference of Professor A.T. Verma sir, we have considered average cross-sectional area, which is in the schematic figures means we have considered over here. This is the schematic diagrams means of the fingers at the level X in the finger abbreviation phenomenon, in the finger abbreviation phenomenon, in the finger abbreviation phenomenon and homogeneous porous matrix we have cited over here. Now let me come on why we have considered over here the schematic representation over here. Actually, just I said in the figure one. Actually, just I said in figure one, at the middle we are able to see at the common interface means the amount of the saturations means we are able to whatever the way the means when we have injected water on the other side and oil has started to mix with the injected water, and because of this slight amount of shift means actually uh, uh, to occurrence of these situations actually not enough very good amount of speed amount of the velocity means should be over there for the injected water. Good amount of force means we need to from the injected water. Fine. And then onwards at the middle of that porous matrix slightly able to over here. Fine. In the schematic can be considered it is the construction of this mathematical model. This is very main means in the phenomenon over here. Actually, in these descriptions, you all are able to see maybe expression or equation 1 and 2 over here. Actually, if I will say this expression 1, where you are able to see it is V suffix, capital V suffix IW. It is velocity of the injected water. And actually, this means as per the reference of Henry Darcy, as per Darcy law means over here means have represented the seepage velocity of the water and oil over here. So in expression 1, it is the first velocity of the injected water, and in the expression number 2, it is the velocity of the native liquid, means oil means. Fine. And if we see the equations means is over here. It is over here. Capital K, if you will see over here, capital K, it is permeability over here. The same way you will be able to see mu is over here. Capital VIW and capital V suffix IW and capital V suffix N0 I said yeah, this is the velocity of the injected water and native oil respectively over here. Fine. And then K suffix actually in my the notation what I have explained over here, it is in capital form I have written over here, and when I have typed in the expression 1 and 2, it is small k. So small k suffix IW and small k suffix and 0, it is the relative permeability. It is the relative permeability of the injected water and native oil. Fine. And which is also in the form of the saturation. It is attached with the in form of the saturation over here. And over here even you will be able to see in the expression on 1 to rate of change of pressure along the x-axis over here. Fine. So here P suffix IW and P suffix and 0, it is the pressure, related pressure of the injected water and native oil over here. And this mu suffix IW and mu suffix N0, it is the constant kinematic viscosity of the injected water and native oil here respectively. So here actually when we will implement in the equation of continuity over there in the expression number 3 and even in the expression number 4, this phi is the porosity. Actually phi over here in the expression 3 and 4, it is the porosity of the homogeneous porous media with constant. Just I said before the entering in the model, I said the heterogeneity and homogeneous. Homogeneous means no variation will be there in the property of the porous. Will be as it is. Okay? As it is means this role will be there at the time of the procedure over here. Fine. So, see, and then in the expression number 5 as per the reference of H. Heidegger, it is taken capital V suffix IW. It is the opposite with opposite sign of V suffix N0 means just I said in the figure 1, when injected water is tried to means with the good amount of force we have injected towards the native oil, then both velocity will be in the opposite direction. And for the simplification of this model over here, it is considered the relationships for the capillary pressures over here, and even this we have cited to the reference, this reference over here, and this PC capillary pressure, which is the in the form of the related with the saturation. It is the pressure difference between injected water and native oil. Injected water and native oil. And over here in this phenomenon, it is appropriate to assume over here the injected water, it is in linearly flowing through small interconnected capillary in the medium. Just actually even in the problem I had highlighted, those persons who want to work before whatever the way we have considered the approach in the linear form. Yeah, injected water, it is in linearly flowing means still you can make appropriate assumptions. Fine, in your requirement over here. Fine, and and this expression number 7, it is the PC. It is minus beta into S suffix IW. Over here, beta, it is the proportionality constant. It is considered over here. And for the simplification of the this constant model, we have used some standard relations between relative permeability and saturation. And through the reference means we have cited over here, and even the relation between the phase saturation and relative permeability as per the book Muscat and Johnson means we have the expressed over here as expression number 8 over here, over where small k suffix IW, it is means relate with the saturation of the injected water, and even small k suffix N0 means it is also means considered as a saturation of the native liquid, or we can consider 1 minus alpha into saturation of the injected water. And over where alpha, this means the proper that value means as per the reference we have means used over here. Fine, in the relation. And then the formulation of this concerned mathematical model for this finger amelioration phenomenon in this porous matrix, it is cited here. See, in the expression number 9, if you will see, I have expressed over here rate of change of pressure of the injected water with this relation. What we means before it we have done over here actually means for these formulations means the whatever we have implemented equation of continuity for the saturation means it is means value we have substituted this velocity of the injected water and velocity of the native oil. Fine, over there in the expression number 6, and that means we can say about the 9, and then we have substituted again into in the value of the equation 9 into in the expression 1. 1 matlab mein 1 and 2 matlab mein the velocity of the injected water and velocity of the native oil. Fine, in the equation 1. So
Sorry
then
to
onwards
interrupt
we
you,
can
ma'am.
say
Ma'am,
yes, madam.
there are 10 more minutes to go. So I was just
Ah,
reminding
yeah,
you.
yeah. Okay, no problem, madam. So means when we will substitute in the expression equation one means our that the as per the concept of the reference of the Darcy law. Fine. In that means when we will substitute then expression or equation number 10 we can obtain over here. Then when we are combining the whatever the means the simplifications, and when we will substitute as equal as the involvement of the like capillary pressure. Fine. And then onwards means then expression on equation 11, and then after simplification I can say this concern expression number 13, over where we people can see the rate of change of saturation of the injected water. Fine, and the middle form we are able to see sometimes what happens in the heterogeneity. In the heterogeneity medium, what happens? The role of this K will vary. Even over there, in reference of Professor A.P. Verma said in our work, when we had worked with in the work with Kinjal Patel, fine, with Professor A.P. Verma sir and Mehta sir, over there K we have shown in the form of in the form of variation. Fine. And even related to it, so many other mathematical approximate analytical methods. The many researchers they have worked under the supervision of Professor V.H. Pradhan sir in our department. So so many means that the way means the logic it is implemented even over here. Fine, and yeah, I can say over here this is the constant non-linear partial differential equation. This expression number 13, which expresses itself as a one-dimensional mathematical model for this concerned mathematical structure in the porous media. Actually, the way we person are giving the own scope to attach with the application of our use of mathematics, right? So over here, see, again we have used as consideration of the saturation of the injected water at common interface. जो मैंने what I have seen in the figure number 1, at the middle of the porous matrix, over where when x is 0, over where x is 0 is very small, that we have assumed as a capital S suffix W0. Fine. कि जब time t greater than 0, time 0 से आगे पर मतलब है, in that circumstances means when x is 0, this much amount of saturation. This is the conditions we are setting over here for the discussions of this concerned non-linear partial differential equation in this model over here. Right, so this is the condition number 14 means it is designed over here. Then we have considered initial saturations. See these expressions when you are able to see capital S suffix W0 into e to the power x by l. Actually, this is our own what I can say as per the neatness in our outlook of the saturation of the injected water that we have assumed in the form of exponential form. In the form of the exponential form. Fine. So yeah, and even we have highlighted over here whatever we have guessed at this moment over here. That this quantity will be less than capital S suffix W0. Fine. And even that we have expressed in the condition number 15 over here कि जब time t0 at initial condition. Fine. कि जो ये expression है capital I suffix W0 into e to the power x by l, that expression we have guessed over here capital S suffix WC. This capital S suffix WC means over where See over there in this figure one, if I will show you systematically, see in this figure one, sorry, figure two है, yeah, over here at a common interface, yeah, let me come on that point. Yeah, at a common interface. Fine. This expression 15. So here, this expression 13, and together with the construction of these two conditions, can say it is the concern non-linear partial differential equations means can describe means as a mathematical model for this concern phenomenon in homogeneous porous matrix. See, Valley researchers, we are working with the fractured porous media, slightly fractured porous media. See, even over there with slightly fractured porous media and fractured porous media, even in that concept, little bit amount of the variation of the whatever properties of the fluid itself and medium itself will be there, homogeneous or maybe heterogeneous. Or even too much work means is over here. Means till date means it is here. So actually solutions, even I need 1 more hour to cover this homotopy analysis method. Okay, no problem, but I will only give brief. Whatever structure I have derived over here as per expression 13 and 14 and 15 over here, this structure we have discussed in our solutions with the concept of the homotopy analysis method. So because of this much time limit, I am not able to take that solution. So only structure I have shown to all the viewers and participants and the researchers, those who are really means they have their own view they have, until they can work with this porous with fractured porous media, slightly fractured porous media, even in the presence of the magnetic field effect, even they can enroll, and still they can see the whatever the changes will be there as per the whatever Darcy law means we have implemented and whatever the other axioms we have cited to our books of the porous. So yeah, madam, I will stop your time. Hello.
Yes, ma'am.
Anybody have any question? Then you can ask me.
So I request participant to ask questions, if any.
Can we convert this non-linear PDE to? Can we convert this? Yeah, ma'am. Question I have seen over here. Can we convert this non-linear partial differential equation to linear? Yeah, sure. We can convert this non-linear PDE to ODE. Even if the transformations are over here, and with that, even the way means we want to divert the path of the concerned non-linear partial differential equation. Still, means we can work. Am I audible? Na?
Yes, ma'am. Any other questions? So I think, ma'am, there is no other question.
No question. Oh, means everybody got whatever I spoke over here. Actually, ma'am, solutions I was not able to cover up in 1 or 2
Yes,
minutes.
ma'am. It is a very wide topic. Yes, yes. But whatever you have explained, we have understood that.
Actually, what I felt unknown will be there. Then, if it is possible, then address everything. Then that interest they can develop.
Yes, ma'am.
This is my view. Okay, thank you, ma'am.
So I would like to thank ma'am for accepting our invitation and for giving such a nice, knowledgeable session. I would also like to extend my thanks to all the participants of this webinar and also to the organizing team. Thank you very much.